Okay, let's now solve some more of these equations on the test review. We've gone through a pretty thorough explanation of what we're doing. So let's look at this. Like problem here, number 5 is 1 minus cosine theta equals 1/2. So we're going to go through these pretty quickly now that I spent a lot of time in the previous video explaining what we're doing. So here, once again, it's like a two-step process. Let's solve for the trig function. Get the trig function by itself on one side. And then we will look and figure out what theta, what angle, will be the solution. So once again, the goal is to find the angle theta that makes this equation true. I will go ahead and subtract 1 from both sides. So negative cosine theta equals negative 1/2. What I want is to have cosine theta. So I will either multiply or divide both sides by -1, whichever you want to do. You end up with cosine theta equals 1/2. So here we go. We solve for the trig function. Now I want to solve for theta. And once again, for these problems, you're asked to give both the general form of the solution and then secondly, the specific solution between 0 and 2 pi. So the general form, once again, what we do, we go think about the unit circle. Since I'm looking at cosine, I'm going to go to the unit circle and I'm going to start looking at my special points, and I'm going to try and find the points or the angles where the x value, since the cosine is the x coordinate, where the x coordinate of the points are 1/2. And if I think about it, and this is where you have to really memorize the unit circle, I know my 3 points here, that point right there, which is pi over 3, the x coordinate of that point is 1/2. Now once I go to quadrant 2 and 3, the cosines of those angles are negative, since I'm looking at the x coordinate. However, when I get back to quadrant 4, I know that this point down here, that angle, which is 5 pi over 3, the cosine of 5 pi over 3, when I look at that point, the x coordinate is also 1/2, so that's also a solution. So for the unit circle, I have 2 possible solutions. So what I do is for the general solution, so here's the general solution, I take that first angle, pi over 3, but then I realize I could go around the circle as many times as I want, and I'm going to end up back at that same point, which means the cosine of that angle will be 1/2. So I simply say pi over 3 plus 2 pi n. And for the second angle, the 5 pi over 3, it's the same idea. 5 pi over 3 is a solution, but if I start going and making many trips around the unit circle, the way I express that is 2 pi over n. So that's the general form of the solution. Now, if they say, just give the specific solutions when we limit the angles to 0 to 2 pi, or 1 trip around the unit circle, easiest way to do it is to start plugging in numbers for n. We start with n is 0. When n is 0, this equation gives me a solution of pi over 3, which is within my range. The second equation, when n is 0, gives me 5 pi over 3. Now, let's see if there are more solutions, more values of theta that's between 0 and 2 pi. So when I plug in n equals to 1, hopefully you can see pretty easily, when n is 1, I have pi over 3 plus 2n. Well, obviously, if you're adding pi over 3 to 2 pi, I think I said that backwards. So we have, when n is 1, we have pi over 3 plus 2 pi, which is obviously going to be larger than 2 pi. So that solution is not within my allowed interval. And the second equation, if I set n equal to 1, I have 5 pi over 3 plus 2 pi. Once again, that's outside the interval I'm looking at. So for the specific solution, there it is. All right, so up until problem 10, they're all pretty much like this. Problem 11, we face a new twist. So I'm going to now jump to problem 11, which is cosine of 2 theta equals negative 1/2. What's the difference? Well, the big difference is, if you look at the problem I just did, my trig function was just cosine theta. There was nothing else inside the trig function but my angle. As a matter of fact, the problem I did on the previous video, if I go way back, you notice here, it was just sine theta. The difference now is, look what's inside my trig function. I don't just have the angle, I now have 2 theta. And that's going to change some things. But here's the way I like to do these problems. First of all, I've already solved for my trig function. They gave me this problem, and there it's already solved for the trig function. The trig function is by itself on one side. What I have to do now is, I'm going to do a substitution. Instead of worrying about this 2 theta, I'm instead going to temporarily call 2 theta u. So in a sense, what I'm doing, I'm saying u equals 2 theta. So I'm going to rewrite this equation as cosine of u equals negative 1/2. Now, I can solve this. U is going to be an angle. And for the general form, I think to myself, where on the unit circle, what angles is the cosine negative 1/2? Or in other words, look at all the points on the unit circle and go find any points where the x coordinate is negative 1/2. And if I think about the unit circle, if the x coordinate is negative, I know it's got to be in either quadrant 2 or quadrant 3. And I think about my special points, and then I realize that point right there is where the cosine is negative 1/2. And that angle is actually 2 pi over 3. And then I realize this angle down here, the cosine of that is also negative 1/2. And that is 4 pi over 3. So for my solution u, and I'm going to write in the general form, the first one I say is 2 pi over 3, and then I realize that I can keep adding on 2 pi's forever and ever, so I say plus 2 pi over n, and then my second solution is 4 pi over 3 plus 2 pi n. So that's good, although really, I'm not really done. It feels like I'm sort of done. I've solved for it, but I haven't really, because if I look at my original problem, I'm trying to solve for theta. And on my own, I created this variable u, but I'm not really trying to solve for u, I'm trying to solve for theta. So what I'm going to do now is, I need to go from u back to theta. So I'm going to take this solution for u, and realize that u equals 2 theta, so now I can just set this thing equal to 2 theta, and now solve for theta. And I can do the same thing to the second solution. So what I'm going to do is now, I'm going to divide everything on both sides by 2. Now these first terms are a little tricky. Let's go off to the side in case some of you are wondering. I have 2 pi over 3 divided by 2. Now you can either memorize the rule of what happens, or if you need help in remembering what happens here, if I think of that as a fraction, I can change this to take the top fraction, multiply it by the reciprocal of the bottom fraction, and I end up with just pi over 3. So when I do that, my first solution now becomes pi over 3. 2 pi n over 2, the 2's cancel, it's just pi times n. Whoops. I'm going to call this theta now. And for the second one, this actually becomes 2 pi over 3. 2 pi n over 2 is once again pi theta, or pi. So now my general form is pi over 3 plus pi n and 2 pi over 3 plus pi n. But now I want to also give the solutions between 0 and 2 pi. So what do I have to do? Now I start plugging in values of n. So let's see what happens when n is 0. When n is 0, let's see what kind of solutions I get. In my first equation, when n is 0, I end up with just pi over 3. For the second equation, when n is 0, I get 2 pi over 3. Both of these angles are between 0 and 2 pi, so they are the solutions I'm looking for. But let's see if there are more solutions. How about when I look at n equal to 1? When I plug in n equals to 1 in my first equation, pi over 3 plus pi. Pi over 3 plus pi, I can change pi to 3 pi over 3. So that ends up being 4 pi over 3, which is still less than 2 pi. So that's another solution. And when I plug in n equals 1 into my second equation here, 2 pi over 3 plus pi, that's actually 5 pi over 3, which is still less than 2 pi. So now if I keep going, if I set n equal to 2, and look at these equations, hopefully right away, once I set n equal to 2, then I've got pi over 3 plus 2 pi, which is obviously going to be larger than 2 pi, and the same thing happens with the second equation. But now, turns out, I end up having 4 solutions. So a quick review is, when you have something besides theta inside your trig function, easiest thing is just to rename it as u and to solve the trig function for u. And then once you do that, then you convert it back to your theta, and then you can finally solve for theta and then figure out your specific problems. All right, so I'll make another video and do a few more things.